An Earth asteroid impact triggered volcanic eruptions and extinctions 67 million years ago. It's believed that the Chicxulub crater of the Yucatan Peninsula has been caused by an asteroid impact, and there is some evidence to link the Deccan Traps eruption to the asteroid impact which created the Chicxulub crater in the Mexican state of Yucatan. Although the Deccan Traps began erupting well before the impact, argon and argon dating suggests that the impact may have caused an increase in permeability, allowing magma to reach the surface and produce the most voluminous flows, accounting for around 70% of the volume. The combination of the asteroid impact and the resulting increase in the eruptive volume may have been responsible for the mass extinction that occurred at the time that separates the Cretaceous and the Paleogene periods, known as the KPJ boundary. The Deccan Traps are a large igneous province located in the Deccan Plateau of the west central India area and are one of the largest volcanic features on Earth. They consist of multiple layers of solidified flood basalt. Basalt lava is what we recently saw erupting in Kilauea, the Hawaii's hotspot. So this is the same type of solidified basalt, and together they are more than 2,000 meters or 6,600 feet thick, covering an area of 500,000 kilometers, that's 200,000 square miles, and have a volume of 1 million cubic kilometers or 200,000 cubic miles. Originally, the Deccan Traps have covered more than that, 1,500,000 or 600,000 square miles, cubic miles, and with a correspondingly larger original volume. The term trap has been used in geology since 1785 for such rock formations. It's derived from the Scandinavian word for stairs or trappa, and they refer to the step-like hills forming the landscape in the area. The Deccan Traps began forming 66.25 million years ago at the end of the Cretaceous period. The bulk of the volcanic eruption occurred at the Western Ghats some 66 million years ago, and this series of eruptions may have lasted less than 30,000 years in total. The original area covered by the lava flow is estimated to have been as large as 1 million kilometers, approximately half the size of today's modern India. The Deccan Traps region was reduced to its current size by erosion and plate tectonics. The present area of the directly observable lava flows is about 500,000 square kilometers or 200,000 square miles. Now, what was the effect on mass extinction and the climate? The release of the volcanic gases, particular sulfur dioxide, during the formation of the traps contributed to climate change. Data points to an average drop in temperature of 2 degrees Celsius in this period. Because of its magnitude, scientists formerly speculated that the gases released during the formation of the Deccan Traps played a role in the Cretaceous Paleogene or KPJ extinction event, also known as the Cretaceous Tertiary extinction. It was theorized that sudden cooling due to sulfurous volcanic gases released by the formation of the traps and localized gas concentrations may have contributed significantly to the KPG as well as their other mass extinctions. But current consensus among the scientific community is that the extinction was triggered by an asteroid impact, the Chicxulub impact event in North America, which would have produced a sunlight-blocking dust cloud that killed much of the plant life and reduced global temperature, called an impact winter. Work published in 2014 by geologist Kertai Keller and others in the timing of the Deccan volcanism suggests that extinction may have been caused by both the volcanism and the asteroid impact event. This was followed by a similar study in 2015. The petrology, the rock formation in the area. Within the Deccan Tramps, at least 95% of the lavas are tholeiolitic basalts, or rock types present include alkali basalt, nephelinite, lamprophrite, and carbonatite. Mantle xenoliths have been described from Kutch, northwestern India, and elsewhere in the western Deccan. And what about the fossils in these Deccan Tramps? The Deccan Tramps are famous for the beds of fossils that have been found between the layers of lava. Particularly well-known species include the frog Oxyglossus pusillus, that's Owen, and the Eocene of India, and the toothed frog Indobatrachus, an early lineage of modern frogs, which is now placed in the Australian family Myovatracheae. The infratrapean and the intertrapean beds also contain fossils of freshwater mollusks. As we said, there is a theory of formation. It's postulated that the Deccan Tramps eruption was associated with a deep mantle plume. The area of long-term eruption, or the hotspot, known as the Reunion hotspot, is suspected of both causing the Deccan Tramps eruption and opening the rift that once separated the Seychelles Plateau from India. A mantle plume is an upwelling of abnormally hot rock within the Earth's mantle. As the heads of mantle plumes can partly melt when they reach shallow depths, they're often invoked as the cause of volcanic hotspots, such as Hawaii or Iceland, and large igneous provinces such as the Deccan in India and the Siberian Tramps. Some such volcanic regions lie far from the tectonic plate boundaries, while others represent unusually large volume volcanism near plate boundaries or in large igneous provinces. And so this is one of the theories of formation, the Deccan Tramps eruption associated with a deep mantle plume, area of long-term eruption hotspot at the Reunion hotspot, suspected of causing the Deccan Tramps eruption and opening the rift that once separated Seychelles Plateau from India. Seafloor spreading at the boundary between the Indian and African plates subsequently pushed India north over the plume, which now lies under Reunion Island and the Indian Ocean, southwest of India. This mantle plume model has, however, been challenged. The data continue to emerge supporting the plume model, the motion of the Indian tectonic plate, and the eruptive history of the Deccan Tramps shows strong correlations. Based on data from marine magnetic profiles, a pulse of unusually rapid plate motion begins at the same time as the first pulse of Deccan flood basalts, which is dated at 67 million years ago. The spreading rate rapidly increased and reached a maximum at the same time as the peak basaltic eruptions. The spreading rate then dropped off, with a decrease occurring around 63 million years ago, by which time the main phase of Deccan volcanism ended. This correlation is seen as driven by plume dynamics. The Indian-African plates motions have also been shown to be coupled with the common element being the position of these plates relative to the location of the Reunion plume head. The onset of accelerated motion of India coincides with a large slowing of the rate of counterclockwise rotation of Africa. The close correlations between the plate motions suggest they were both driven by the force of the Reunion plume. And there also are suggested links to the impact events, the Chicxulub crater from the asteroid impact in the Mexican Yucatan Peninsula. There is evidence to link the Deccan Tramps eruptions from an asteroid impact that happened half a world away in the Mexican state of Yucatan. created by the Chicxulub impact. And that's where we have the Chicxulub crater. Although the Deccan Traps began erupting well before the impact, argon-argon dating suggests that the impact may have caused an increase in the permeability that allowed magma to reach the surface and produce the most voluminous flows, accounting for around 70% of the volume. The combination of the asteroid impact and the resulting increase in eruptive volume may have been responsible for the mass extinctions that occurred at the time that separates the Cretaceous and the Paleogene periods, known as the KPG boundary. A geological structure exists in the seafloor of the west coast of India, and it's been suggested as a possible impact crater, in this context called the Shiva crater. It has also been dated at approximately 66 million years ago, potentially matching the Deccan Traps. The researchers claim that this feature is an impact crater and suggest that the impact may have been the triggering event of the Deccan Traps, as well as contributing to the acceleration of the Indian plate in the early Paleogene. However, the current consensus in the earth science community is that this feature is unlikely to be an actual impact crater. Kindly support by contributing to my Patreon account. You'll find it in the description box below. Thank you.